What I wanted to sort of, now we sort of talked about conceptually, big ideas for EWN. How do we implement these in WMS and GSHA? So this is much more of a how-to guide. So one of the things that Chuck talked about way back at the beginning yesterday was grid resolution. And how big is your grid resolution compared to the thing that you're trying to model, right? If the thing you're trying to model is less than a gigabyte, you have to be able to physically model. You have to sort of tweak the cell parameters to sort of simulate, right? If it's more than a grid size, then you can physically simulate, right? So I'll say now where you can choose your grid size. So sort of take that into account when you're thinking through courses of action and how big they are and such. But this sort of scale of the thing that you're trying to implement versus the scale of your model, you've got to balance those. So in all of these sort of recipes, there's this balance, right? Of how big is the thing compared to the cell size. So if the thing you're trying to change is like multiple grid cell sizes big, well, then we can actually do the physical process changes. We can look at land use changes, we'll look at wetlands, retention basins, whatever. If it's less than a grid cell size, we're going to approximate the effects. So we can use retention depth to help retain some water, so we can sort of calculate what's the volume of retention. Spread that over cell size, figure out retention depth differences, change the hydraulic connectivity to infiltrate more water, or change the roughness to slow down the water, right? We can approximate something smaller. Next year we'll have subgrid BMPs that we can implement, so there'll be more coming in the future, but not quite yet. Land use change. So probably can spend a lot of time, and just a few minutes, working through land use change. Okay? We've sort of seen now, like with the infiltration, how you can take a GIS layer, map that into an index map, and use that to drive your parameter set for the spatial discretization of the different parts and pieces of the watershed. Changing that is very often sort of the heart of a GSHA model, right? So I saw with my Mishawaka model, so it was a bunch of different land use changes, right? So coming up with those, how do you do that, right? That's usually sort of a team effort. Somebody is thinking through these are the parts and pieces of need to change. This is where they go. And then somebody's got to work with the GIS data to massage all the polygons in the right place. Make it happen. There's really, since this is the recipes method here, there's really like 3 ways you can go about actually changing an index map. So use QGIS or ArcGIS or some sort of GIS tool that actually create polygons and spend the time and the effort to work out actual GIS layers, right? Great way to do it. Especially if you have somebody who's really good at GIS. WMS has quite a few GIS capabilities, not as sort of broad as GIS tools, general purpose GIS tools, but there's actually quite a few GIS tools inside of WMS that you can do a lot of the manipulation and changes within WMS. So you don't have to go outside WMS to change and control that. And then there's always sort of the simple go-to method where you just change the actual numbers in the index map. At the end of the day, when you're running the GSHA model, that's what you need to change is the index map, right? So you can manually change the number in the index map. That works. So this is the manual mode. So when you're in the 2D grid module, just choose the select a cell, right? And then it'll pop up the index map here, so you can make sure you chose the right index map that you want to adjust. Just type in a different number, and you can change your index map. Right? So that's how all of these are ski slopes that are part of ski wall. Like somebody turned to just sort of walk down a picture of where the ski slopes are and put in a different number. Now, backing up, so GIS editing in WMS. How do we do the GIS editing in WMS, right? It's actually really simple and straightforward. So step one, you're gonna, whatever coverage you're looking at, whether it's land use, soil, whatever it is, take copy what you're gonna work on change, okay? So you just right click on it, duplicate. Select it, so we never edit right on. That's not right, and it didn't select it. You just, right here is all those little map module tools that Chris showed. So this right down here is like the add feature arc. Just click in, where you're going to go. Like if you've got some imagery in the background, or some near a stream or something like that, you kind of know where things are at. You can work off of that. Click it in. Work too hard. And up in the feature objects menu, you say build polygon. It'll ask you, do you want to use all the arcs? And say yes. And then that's it. Right? So now you've got a new polygon. You can select the polygon, double click it, and assign a new land use. And then you have a new ID for that. Now we're still at the coverage level. We haven't changed to it yet. So then just walk through the process you just did. Okay. Go through the map module to create the index map, and boom, there it is. Right. So there's usually enough GIS editing tools within WMS that you can spend the time editing land uses or soil types or whatever you need. And it's pretty straightforward. Questions there? Yes.
Would the benefit of using WMS for GIS editing be just like, so you have everything all in one place, or if you don't have an ARC subscription, or those types of things?
All the above, yes.
Is there any other benefit?
It's doing it in GIS, you don't need to export it and then sort of import it and then map it to the earth. So as long as you know that process, that's not a hard thing to do. You're like, you love GIS and you're in that world every day, go for it. But not everybody loves editing shapes in GIS every day. So this could be a good alternative to simple.
Okay.
Yeah. Both work good. All right, modeling wetlands. So again, this sort of goes back to the scale question. Are your wetlands, smaller than your grid cell, or is it bigger than your grid cell? Are you going to do two different things? Smaller than your grid cell, you're going to sort of add some retention depth and increase your roughness. Well, you can do. Okay. Larger scale wetlands, that's where the fun. That's so we can actually start to get into the physics of how to model a wetland. So so this is Chuck showed this slide yesterday. This is sort of the physics model of how GSSHA handles wetlands. So it's really about the hydrodynamics of flow through the vegetation and the peat muck layer below the vegetation. So if you're doing a constructed wetlands and somebody's put like a liner below your wetland, or a clay liner or something like that, or they've got some outlet controls, those would be additions to this. This is the hydrodynamics part of the wetland. So it operates on a cell. Each one of these bars looks like a cell. Okay. So in a cell, you've got some depth of the peat muck layer, and you've got some height of vegetation layer. Because you're gonna have an insurance, but I'm pointing out all these parameters and parameters you have to come up with for your thought. You're gonna have an initial depth of water. Whatever it is. You need a hydraulic conductivity for flow through your peak pump layer. You need a hydraulic conductivity for flow through like basically the bottom of your vegetation layer. And you need a roughness value for if water is deep enough that it's your wetland vegetation is completely soaked. Okay. Those are kind of the three key flow parameters there. So what's going to happen if the water is only down at the peak up layer? Water will only compute this direction flow through peak up layer. If the water is in the vegetation zone, it will compute two different flows. One is direction flow, so you know the whole layer, the whole depth, right? And the other is the turbulent flow. This is magnetism, back to the equation to John walk through this. It has a linear interpolation depending upon your height from 0 to 1 of how the water is in the vegetation area. So this sort of assumes the more water in your vegetation layer, the more bent over all the vegetation is, and it's sort of transitioning itself from forest medial flow to turbulent. So that's that transition. At the bottom, we still have infiltration. So those are the different parameters that you're going to put into the WMS. So building wetlands in WMS. It can be a little tricky if you don't do it just right. So this is the just right steps. Okay. Use these. You're in the GSSHA module. The GSSHA cover. Sorry. Choose the select feature arc tool or create feature arc tool. Pick out one or more wetland areas. Okay. Then select your arcs. The select feature arc tool. Build feature arcs. Build polygons. Okay. So you need to build polygons here. If you do one at a time, it won't work right. You need to select all of the arcs, make them all at once. It'll make them individual wetlands. But if you do it one at a time, you'll just get one back.
Sorry, I have a question.
Yes.
When it comes to placement of wetlands, is that just done outside of anything with WMS? Like just your own design and field work and site analysis? And
Yeah.
There isn't any capability of it to suggest locations for you?
So this would be where you sit down with the team going, what if we had a wetland here and the sort of spitball, oh, this would be about a good size. And then you go talk to some biologists and they're like, oh, no, you did it.
So just like see what happens once you figure out where you might want it.
Yeah. Then you go back and refine there.
So on that, when you were doing the different wetlands
Yes.
that you were looking at, can you, like, do you have one that you know your size and everything like that? Can you pick up that polygon, move it around? Or is it?
You can't like pick up, you gotta drill it around. My point is cookie cutter, I should get it out.
Okay.
That would be fun. Yeah, once you've got your polygons built, then you sort of pick the select polygon tool, double click it, and that brings up the attributes of the polygon. Take to wetland, and these are all the numbers that you got to fill in. Right here. So initial storage depth, retention depth, hydraulic connectivity, vegetation height, blah, blah, blah. And you repeat for all the wetlands. That's it. That's all you have to do to have a wetland. So notes on wetlands. So if when I was looking at a lot of these constructed wetlands, they were like, oh, we have a clay line underneath it to make sure we're holding in water or whatever. So if your design of the constructed wetland has a clay liner, well, you're gonna want to change the soil type. Right? Otherwise, it'll just leave right now. Right, constructed wetlands have berms or earthworks or things like that, outlet controls. It's gonna be in there. A large scale constructed wetlands often involve different bays, different levels and such. So they can get quite complex how they do these things. Here's my bonus content since you guys have all been great students and managed to stay this far. In the mapping tables, not in WMS, but in the mapping tables. If you ever find yourself in a situation where you're like, they're gonna go excavate my wetlands and dig down, a meter or whatever it is, you can actually add another column right here in the list of columns. Not WMS is gonna go edit this manually, but you can add in like a burn-in depth so that it's calculated. Let me stop there. Questions on wetlands?
So is that's in GSSHA that you're doing the burn-in column?
So,
Correct.
so these, we haven't really shown, I should show you guys the files. I'll show you guys in a minute. So when WMS goes to run GSSHA, you save the file, it's actually saving like a couple dozen different files. One of those has this .cnv.
Okay.
That's the one that has the mapping tables. So that has all those tables for roughness or, initial soil moisture or all the soil properties. So that's all in that one big file.
So you go in.
Head it down. It won't show back up in WMS. So it's a bad. Yes.
I have a question on the review time actually. I'm still thinking about it. Can you, instead of building the wetlands in there and drawing them, can you take an ArcGIS file and import it with already polygons in it?
You can for sure.
Or, but like if you have the imagery of it, you could use that to trace.
Yeah, you can do that. Either one.
Yeah, you have to save file as a picture, polygon, and then convert it to polygon. There is a polygon map. You get the polygon. Right click on that, get that option.
Okay.
Principally the one that you can import a shape file into an existing coverage.
And you just read in the shape file and then convert it to your, add it to your GSHA coverage.
And like you're saying, Haley, if somebody took like a piece of paper and like drew out, here's where I want the wetlands, that's when you're gonna, way back when we talked about image registration and stuff like that, right? You can bring the image, register it, and you've got it, so you can trace that.
Yeah.
That's a comment. One of the things we're gonna have to do for the Salton Sea project is the Salton Sea in Southern California, they want to build 36,000 acres of wetlands all around the margins of the sea. And there's the NRCS and National Research Conservation Service has these CAN designs, which the state of California has said, we're going to build these wetlands and these ponds and these features all to this NRCS conservation practices plan. I have the list here, the 378 CA, CVP bond, whatever. So what we've got to do is get all those ponds, all these designs that the NRCS have got, and basically put them into this. So we'll probably do it by hand because it's the easiest way to do. But we'll have to get all these plans, and they have very specific depths. Part of the wetland is 4.5 feet, part of it's 3 feet, because they want to get certain plants in certain areas for certain birds. And so, so there is a lot of wetland. I guess my point was, if you look at the NRCS, they have a lot of new wetland designs that at least the state of California is saying, we're going to use these designs for this project. So we've got to get them into our GSSHA model.
Cool. Beaver dam analogs. So this again sort of goes back to how big is your beaver dam? Is it really big, medium, small? Essentially, if it's kind of a biggish size, you're going to find a simple vertex somewhere where it's kind of flat, and you think you might want to put beaver dam. Turn your vertex, feed out its vertex to node. That's how you split stream. And then from there, you're going to add some embankment arcs. We just started out a little bit ago. And then you can add in small detention basin and a weir or something like that, whatever your other words you think are appropriate. Something kind of simple, small, like a meter high or something like that, but you're not going very huge. 2 meters wide, something like that. So small little retention basins to help slow the flow of water. So here's one that I was working on last night. So here's sort of 2 different wetland areas with the embankments in between to help sort of make them at different heights. Right? Here's a bunch of different little beaver dams that I added along. So this is really flat through here, so I'm just back quite a bit. It looks like a meter high, flooded quite a ways. So, where do you put them? How many do you add? This sort of goes back to that, my fractal stream analogy. If you're going to want lots of little ones, or, if you're going to spend money, big giant one downstream. I also spent some time when I went through last night. I made sure that my stream was pretty shallow next to the land surface, so that when the water would come down, it could actually overflow into it. And I made it so that right here and right here, where the stream would exit the berm, like I put a weir in there so that it would back up the water into the channel and then from the channel up the overflow. So you got to sort of think through the sequence of all the parts and pieces that it takes to move the water into where you want it.
There,
Yes.
it's too long.
Yes. Is Nathan online?
I was just checking that right now.
Oh,
He's not on, doesn't seem to be on. I'll send him a message though.
okay. So infiltration basins. Basically, you're gonna sort of you can plug down embankments anywhere you want in your watershed, and the water can pond behind them. You don't have to have a.
It doesn't have to be on stream.
Doesn't have to be on stream.
Yeah, okay.
Right here's one where it comes down at the end. Like here it is, at the beginning of the stream, right? Like a weir here, so it starts. The water in the cell right here, you have to get higher than the weir to start flowing. That's right. Multi-scale models. So this is, if you want to make sort of a larger, pretty, coarse scale geisha model, more regional size, but you want to try some, step down and make a small localized model. You put in a lot more detail. Right? You can do that with geisha. It's really easy to make the water from the outside model flow into the smaller model. Right here on the geisha wiki is it tells you what it needs to do. Geisha will go in. All you have to do is in your project file tell it, there's a bigger model I need you to get boundary conditions from. And Geisha will go and figure out all the boundary conditions for you. Overflow, the stream flow, groundwater if necessary. It'll cut out all the data for you and pull it into your little model magically. So you don't have to do anything. Maybe you do lifting to make it happen. There's just a few little cards you'll need to edit. Right here explains that.